Welcome to aminacademy.com. In physics, let us discuss about mechanical properties of fluid. First, fluids are everywhere around us. Earth has an envelope of air and two-thirds of its surface is covered with water. Water is not only necessary for our existence, every mammalian body constitutes mostly of water. All the pressure occurring in living beings, including plants, are mediated by fluids. Thus, understanding the behavior and properties of fluids is important. How are fluids different from solids? What is common in liquids and gases? Unlike a solid, a fluid has no definite shape of its own. Solids and liquids have a fixed volume, whereas a gas fills the entire volume of its container. We have learned in the previous chapters, previous lessons that normally we know that the volume of solids can be changed by stress. The volume of solid, liquid or a gas depends on the stress or pressure acting on it. When we talk about fixed volume of solid or liquid, we mean its volume under atmospheric pressure. The difference between gases and solids or liquid is that for solids or liquids, the change in volume due to change of external pressure is rather small. In other words, solids and liquids have much lower compressibility as compared to gases. Now, in mechanical properties of fluids, mostly about density and pressure, buoyant force and Archimedes principle, fluid dynamics, viscosity, and surface tension. And that first we'll discuss about what is pressure. Pressure is the force applied perpendicular to the surface of an object per unit area over which the force is distributed. Gauge pressure is the pressure relative to the ambient pressure. Look at this. Here, this is the one face of the container. It shows. Suppose a liquid is filled in a closed container. So that molecules of that gases wandering inside in different directions and hits the in particular area of the one face or every face of the container. That means due to continuous impingement of the molecules to the surface of the wall create a pressure. Now, pressure exerted by the liquid. The pressure exerted by a liquid depends on the height of the liquid and the density of the liquid. Pressure exerted by a liquid at the same depth will be the same. Liquids exert pressure in all directions. Here, suppose it's a container having 3 holes put in vertically on the wall. Now look at here. Here under this more height, the pressure is more. Here pressure is middle, here pressure is low. So that water flows more length here middle, and here less length. Because of that, due to height, more height have more pressure. We understand this. Pascal's law. Pascal's, also called Pascal's principle or principle of transmission of fluid pressure, is a principle in fluid mechanics is given by Pascal that states that a pressure change at any point in confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. Look at this. It's a picture for hydraulic press. Look at this one. The piston area is lesser than the lifting area of the car here. Now, everywhere pressure is same. Due to Pascal's law, we can say P1 equal to P2, but we know that P1 pressure 1 equal to force by area and P2 equal to that force by area. Here pressure P1 is equal to P2. From that we can find force required to lift the car. That here force is less, then we can lift with less force, we can lift more weight of the car. Variation of pressure with the depths. Here, the deeper you go under the sea, the greater the pressure of the water pushing down on you. That means you are in the swimming pool, you are going deeper on the swimming pool, the pressure exerted is more on your body because of the depth more. For every 33 feet, that is nearly 10.06 meters, you go down, the pressure is increased by 1 atmosphere. That means every 33 meter going down deeper, you feel 1 atmospheric pressure increase. Many animals that live in sea have not no trouble at all with their high pressure because their body is constructed regarding their living surroundings. Atmospheric pressure and gauge pressure. Here, look at here, atmospheric, absolute, gauge and differential pressures here. This is pressure A, pressure B, C and this is DE. Variation of the different pressure types. Absolute pressure, that is A here, this is called a absolute pressure, and gauge pressure, this is a gauge pressure, and vacuum pressure, this is C. The atmospheric pressure is D in this. The absolute zero pressure E, this absolute zero pressure is here. Pressure is a measure of force per unit area. We know that there are different types of pressure measurements. There are two reference pressures, atmospheric and absolute zero pressure. Atmospheric pressure at sea level is 1.013 bar, nearly equal 14.7 psi, that is pounds per square inch. Absolute zero pressure is theoretically a perfect vacuum. A perfect vacuum's conditions are impossible to create. Even in interstellar space, we cannot create perfectly vacuum. This article discusses the difference between the types of pressure and pressure gauges used to measure them. First, absolute pressure. Absolute pressure is measures that pressure above absolute zero. Differential pressure. Differential pressure is the difference between two different pressure measurements. Gauge. Gauge pressure measures the pressure above the atmospheric pressure. Vacuum pressure measures the pressure below atmospheric pressure. Atmospheric pressure is the pressure on the Earth's surface. First, absolute pressure. Because the absolute pressure uses absolute zero pressure as a reference, it cannot have a negative value. Absolute pressure is the sum of gauge pressure and atmospheric pressure. Absolute pressure gauge are applicable for industrial vacuum pumps, and absolute pressure gauge has a diaphragm with one side contact pressures media and the other connected to a vacuum. Therefore, atmospheric pressure does not influence the diaphragm deformation. Look at this differential pressure. Here, this is a U-tube, and this some part of the area is filled with some mercury, and it is open to atmosphere. Suppose if you give some pressure in this, pressure B is more here, so it press the liquid down. Due to that, this level of liquid increase this one. This difference, this C, the distance C is called a gauge pressure. Differential pressure is a high reading A minus low reading B. That means here, reading of this minus reading of this side is called differential pressure. The result of pressure gauge is the difference between the two pressures. Differential pressure is the difference between two applied pressures. Most pressure readings are technically differential as the pressure is measured relative to atmospheric pressure or absolute vacuum. The differential pressure gauge. A differential pressure gauge has two ports. One port connects the high pressure in the system and one connects a lower pressure. The differential pressure gauge simultaneously measures both pressure and displays the difference between them. A common use of differential pressure gauge is to measure pressure drop across a system components such as a valve. This equipment is called manometers, simple manometers. Gauge pressure. Gauge pressure is a measure of the difference between a system and the surroundings atmospheric pressure. Gauge pressure can be negative or positive depending on whether the system is in vacuum. Pressure gauges have a sensing element, such as a diaphragm that deflects due to the pressure changes. Pressure sensors requires ventilation to us to use atmospheric pressure as their reference point. The gauge pressure is independent of the atmospheric pressure. It does not change with elevation as the gauge pressure always takes local atmospheric pressure into account. Therefore, it is suitable for measuring pressure in pipes and tanks where pressure is higher than atmospheric pressure. What is vacuum pressure? Vacuum pressure is also known as a negative gauge pressure. Pressure gauges read zero at atmospheric pressure. Lower to that is called a vacuum pressure. Atmospheric pressure, atmospheric or barometric pressure is the force that are above a surface exerts on the surface. Atmospheric pressure lowers as altitude increases. That means you are going higher and higher above the earth, the pressure is reducing. At sea level, atmospheric pressure is approximately 1.013 bar or 14.7 psi. Here, hydraulic machines use the difference in force in different cross-sectional areas. Hydraulic machines are liquid fluid power to perform work. Heavy construction vehicles are a common example. In this type, a machine, hydraulic fluid is pumped into various hydraulic motors and hydraulic cylinders throughout the machines and becomes pressurized according to the resistance present. The fluid is controlled directly or automatically by control valve and distributed through hoses, tubes or pipes. Here pressure is exerted here by using a motor, the oil compressed by through a less cross-sectional area piston, and it is continued here with a larger cross-sectional area because we had to lift higher forces. That means our load is heavier here. We are giving less force and we get more force in this. That's some mechanical advantage is used here. Now, so far we discussed about different types of pressure and with details. Further discussion we'll do in next videos. We have done. Please subscribe our YouTube channel.